So have you ever wondered what is actually out there in our solar system? What is actually orbiting our sun other than Earth? So in the last chapter, we read a little bit about like how the Earth orbits the sun and what that looks like. But what else also does that same thing? So in the solar system video, you got to see that there are 8 planets that orbit our sun. And a planet is just a large spherical object that has more mass than everything nearby to it. So in the realm of like space and like things you find in space, scientists classify them basically according to their size and what they're made out of. So planets are large spherical objects that have a lot more mass than everything around them. So their size is huge. They're big. But there's other stuff. So we also have things like dwarf planets. So Pluto, rest in peace Pluto, is a dwarf planet. And a dwarf planet is a planet that just isn't as large as a normal planet. Its mass might not be bigger than things that are around it. But it is round and it is spherical. But there are things that aren't spherical, and so they don't fall into the dwarf planet category. So asteroids there's literally like millions and millions of these things. An asteroid is simply a rocky thing orbiting the sun. And it could be really small, there's really small tiny asteroids, or it could be huge. It could be really, really big. But they don't tend to be spherical, and they're just rocks that are floating out there in space. They're just random debris. That's what an asteroid is. There are also things like comets. Comets are orbiting the sun, but they are not always made out of rock. They have a little bit of rocky stuff in them, but they're also made mostly out of ice and dust, which is why comets have these long tails that come out behind them as they're orbiting through space. You can see this with like a telescope. Those tails come from the ice and the dust streaming out behind them as they fly through the sun's radiation. The sun's radiation like knocks little pieces off of them and creates that spray of things following them along. So we have planets, we have dwarf planets, we have asteroids, and we have comets. Comets tend to be fairly small as well. They're usually a little bit smaller than asteroids, but not always. There can be some that are larger. But they're made of dust, ice, and frozen and gases and things like that. They're not as solid as asteroids are. Okay, so that's pretty much everything that you'll find. But how do we actually know where this stuff is? So we can use telescopes to look out at the night sky. And a long time ago, scientists from like the 1700s and 1800s would use telescopes, and they would notice that some stars would seem to move. And that's where we figured out first that planets exist, because planets look like stars in the sky that are actually just moving over time. Most stars look like they're standing completely still. But once we got into more like scientific or technological studies of the solar system, we needed a way to measure these humongous distances. So the distance from the Earth to the sun is a staggering 150 million miles. It's incredible. But that distance is actually the unit of measurement that we use. It's called an astronomical unit, and it is used to measure the distances between planets. For example, Neptune, which is the farthest out planet in our solar system, is 30.05 astronomical units away from the sun. So that means that it's 30 times farther away from the sun than we are. It's absolutely insane, the amount of distance and the amount of size and space that you'll find even in our small little solar system. The other way that we measure stuff is by measuring its speed. So the speed of things going around the planet. So we know they're a certain distance away, but how fast are they actually moving? We call the time that it takes for one planet to complete its orbit around the sun its period of revolution. So So we learned, okay, revolving means that it's orbiting around something. So it's the period, the time that it takes it to do that. Also, we can measure the period of rotation, which is the speed of how fast the planet is spinning. Interestingly enough, so our planet is way smaller than the planet Jupiter, which is the largest planet in our solar system. But the planet Jupiter actually has a much faster period of rotation than Earth, so it spins a lot faster than we do. A day on Earth is 24 hours, but a day on Jupiter is about 9 hours. So Jupiter has 2 days plus a little bit before we even have one. It's really weird. So scientists have discovered some really interesting things by measuring certain stuff in our solar system. So that's it for this video.